So, are you guys able to see my screen? Maybe give me a thumbs up if you're able to. Okay, perfect. Thanks. All right, so just a quick introduction before I go into the session, an introduction about myself. So, I'm Anand from Chennai. So, I have a total of 15 years of experience in IT. Have been working in multiple Azure technologies, DevOps, and platform engineering for the past 7 years. That's a quick intro about me. At the end of this session, I'll send my LinkedIn handles and also my website where I post blogs regularly. Okay. Okay. Hello, Salem. All right. So, in today's session, what I'm going to talk about is auto scaling in Azure Kubernetes Service. So, how autoscale works in AKS. AKS is nothing but a Kubernetes service, Kubernetes as a service given by Azure. Okay, so that's what I'm going to talk about today. So, before I deep dive into the topic, I just want to know, hear from any of you. Uh, do you have any of you have experience working in AKS? Just give me a thumbs up, right? Or if you're new, no issues at all. Okay, perfect. All right, thanks Anand and Arvind Nandakumar. All right, so all right, so the topic for today is, as I said, auto scaling in Azure Kubernetes Service, right? And why we are choosing this topic is basically because the auto scaling in AKS is quite different when compared to other Azure resources, right? So for those of you who have worked in Azure cloud, you might have seen auto scaling in virtual machine scale set, app services, and also in other Azure resources, where the scaling might be quite straightforward. For example, if you take virtual machine scale set, the scaling there is very simple, where you configure an auto scaling based on CPU or memory, right? It's quite straightforward. You just configure a threshold. For example, if my CPU reaches some 60 or 70%, scale my instance of my virtual machine scale set, right? So that's how you do in other Azure resources. But when it comes to AKS, Kubernetes in Azure, it's a couple of things involved to achieve the auto scaling. It's not straightforward as other like other resources in Azure. Okay, so that's why I wanted to deep dive into this topic and make it clear the confusions and make it clear for everyone, right? So that's why I've chosen the topic. So agenda for today's session, what I'll show is how autoscaling works in AKS and the two components involved to achieve the autoscaling, which is horizontal pod autoscaler and cluster autoscaler, right? That's what I'm going to talk about today. And not much of theory, okay? Mostly the theory will be less, and I'll be mostly working on the demo, end-to-end demo, okay? All right. So, how do we achieve this auto scaling in AKS? So, to achieve a complete auto scaling in AKS, right, there are two level of scaling, not just a single scaling like you do in VMSS or other Azure resource. There you need to apply this scaling at two levels, right? So, what are those two levels? So, for to understand that, let's first understand how the basics of AKS, right? How does an application work in AKS? Right. So when it comes to AKS, just I'll talk about a little bit of basics about AKS, right? Before, because this is something important for us to understand before we try to understand the auto scaling, right? So how do you host an application in AKS? So basically, you'll have something called as a node pool, which is nothing but a group of nodes. When I say group of nodes, it is nothing but a virtual machine instance of a virtual machine scale set. So think of this as a VM, okay? To make it simple, think of this node as a virtual machine. Inside this virtual machine, you have small pods, okay? Maybe it's called as containers. So you have the smaller units running on top of your virtual machine. I'm saying virtual machine just for example to make things simpler. So you have this pod running on top of a virtual machine, smaller units of pods running on top of this virtual machine. Maybe think of it as a smaller small computers inside your virtual machine. Okay, so your application will be running on top of this pods. So, for example, this virtual machine can host multiple copies of the same application. Okay, maybe it will have some 10 pods, which means 10 replicas of the same application, or also it can host multiple pods, meaning multiple applications running on different pods. So, which means that you can have two different applications, like front end and back end, running in the same virtual machine uh, on different pods. Right, so your pod is nothing but your actual application running on top of your virtual machine. Okay, so this is how a basic AKS cluster works, right? So you have a node virtual machine. On top of the node, you run your application pods, smaller unit of pods. Uh, so that's the structure of an AKS cluster. Now, how do you really scale this whole setup? Right, that's what we want to understand. So, to achieve an auto scaling, right, as I said, you need to scale at two different layers. So, when I say two different layers, so what are those layers? So, the first thing is you need to scale up this pods. Okay. For example, initially you'll start with, let's say that you have an application and you'll start with maybe two pods, right? So what will happen is your users will try to access the application. They'll hit the pod. So their traffic will be sent to pod 1 and pod 2 initially. Okay, and assume that the traffic keeps growing, which means that these pods will not be able to handle that traffic, right? Because these pods will have a certain amount of resource, CPU and memory, so they'll not be able to handle it. So your traffic gets keeps hitting pod 1 and pod 2. They are completely occupied, and maybe your traffic gets congested and users feel get the performance issues and all that. So to tackle this issue, we first scale up the pods. Okay, so what we'll do is we'll set an auto scaling for the pods, which is called as horizontal pod autoscaler in the Kubernetes terms. Okay, so that's the important concept that we need to understand. Horizontal pod autoscaler, which will scale these pods. Okay, so what will happen is your traffic hits pod 1 and pod 2, gets congested, and the autoscaler, horizontal pod autoscaler that we set up, will spin up another pod based on certain conditions, which I'm going to show you in the demo. Okay, so your pod gets increased, the number of pod gets increased through the horizontal pod autoscaler, and your pod will keep growing based on the traffic that the other pod gets. Okay, so based on the traffic your pod gets growing. So let's say that you got some 10 pods. Initially you had two pods, but later, based on the traffic hit, you've got some 10 pods running on top of this node, the virtual machine. So after that, what happens is, because of the number of pods increasing on the virtual machine, your virtual machine at one point gets congested. Okay, it will not be able to handle more pods. So just see how this works hand in hand. Your pod, your user traffic keeps increasing. You've set up an autoscaler for your pod. Your traffic on the your number of pods getting keeps increasing. At one point, your node will not be able to handle more pods. Okay, so that is when we need another scaling at the node level, cluster level, which is called as cluster autoscaler. Okay, so we increase the number of nodes. As you can see here, there is another node, okay, in this diagram. So what will happen is, after 10 pods, for example, your 11th pod, this node will not be able to handle the first node. So it will spin up another node for us, which means another virtual machine will be spinned up, and your pod will be new pod that is not able to get hosted on the first node will be hosted on the second new node. So this node autoscaler will spin up another node, and your pod that was struggling to get scheduled will be hosted on the new node, which got spinned up by the cluster autoscaler. Right. So as I explained, there are two levels of scaling here, which is pod level autoscaler and node level autoscaler. Which is the node level autoscaler is called as cluster autoscaler, okay, which means that we are spinning up another virtual machine instance of a virtual machine scale set, okay. uh, and pod autoscaler, which is called as horizontal pod autoscaler, which spins up, increases the number of pods. Okay, so that's the concept of auto scaling in AKS basically, right? So as I said, that's what I've written here: horizontal pod autoscaler and cluster autoscaler. So the type of autoscaling, right? We have some couple of options, which is this cluster autoscaler is always fixed. Okay, so any type of autoscaling you use, this node has to be auto scaled the same way. Okay, but when it comes to the pod auto scaling the pods, this can be based on a CPU and memory for the pod, or else there is something called as SCADA based auto scaling, which is nothing but based on some event you can auto scale these pods. Just try to understand this, guys. Okay, so you can auto scale this pod using horizontal pod autoscaler, which means that you configure a certain memory and a CPU threshold on this for the pod autoscaler, and based on the CPU memory percentage, your pod gets autoscaled. Okay, that's called as horizontal pod autoscaler. But based on some events, also your pod can get autoscaled. When I say events, let's say that your HTTP traffic is getting increased, right? So based on the traffic and number of requests, you can increase the number of pods, which is called as horizontal pod auto sorry which is called as the KEDA event based auto scaling. Okay, and similarly you can have number of events. Let's say your something lands in your storage account. That can be a trigger point for your pod auto scaling, right? So based on certain events you can auto scale the pods. This is called as KEDA autoscaler. Okay, event based autoscaling. Your pod gets autoscaled, and once your new pods are not able to schedule on the node autoscaler kicks in and it spins up a new node, but the concept is still the same. Okay, so in today's session we'll see the horizontal pod autoscaler and the cluster autoscaler. So we'll configure the a certain threshold for the uh, pod limits, and then based on that threshold will auto scale the nodes. That's what we'll see in today's session. Okay, so with this, let me stop and see if somebody has got any questions so far. So I see 13 participants. Thanks all for joining.
And hope my voice is audible, guys. And just give me a thumbs up, and my screen is all visible, right? Everything is good, I believe. Okay, perfect. Thank you. All right. So I think enough of slides. Okay, so let's jump on to, before I don't want to walk through this, let's jump on to the demo, actual demo, right? So I already have a cluster. I don't want to deploy that in this session. Did not want to deploy this because it takes some 5-10 minutes. So I have this cluster ready, and I have my system node pool, which is hosting the system Kubernetes pods, and I have a user node pool. Okay, so on this node pool, nothing but, as I said, it's a virtual machine scale. So it's a virtual machine. Okay, so all my application I'll be hosting on this user node pool. Okay, so I currently, let me show you before I deploy something the current state of my pods. Okay, I don't have any pods currently running. So you see no resources found in default namespace. So this is my application deployment manifest. Okay, so let me give you a brief overview of this manifest. Okay, so what's written here is, I'm deploying an application that's already a public image. Okay, so just for testing purpose, we have a publicly available image that's being called in this manifest, and I'm creating two replicas of this application, which means two pods I'm creating, and I'm targeting my user node pool to host this pods. I'm targeting my user node pool, which is nothing but the one I showed here. uh, on this node pool I'll be hosting the pods, um, and I'm exposing this application using a load balancer service, because once I deploy this application, this should be accessible publicly, right? I should be able to access this to show for the demo purpose. So that's why I'm exposing this demo app hyphen php using a load balancer service. So whenever I hit, so this will create a public IP for me. So when I access that public IP, it will hit the two replicas. So it will keep sending the connections to the two different pods simultaneously, right? Not simultaneously, I mean, it'll do some load balancing between the two pods. So that's how the application deployment is going to work. Okay, so I'm just going to have this application deployed. So let me first deploy this application into the cluster. Okay, so I have this cloud shell, and I'm going to upload my manifest. Before that, I want to show you the service also. So currently there is only the default cluster IP service. Okay, you don't see any other service. So now I'm going to apply my manifest, which is going to deploy my application pod. Okay, so as you can see here, my manifests have created the deployment and the service. So let me see what has happened in the background. Okay, so two pods are being created in the process of creation, and one more service has got created. The load balancer service has got created. It should get a public IP shortly. So as you can see here, a public IP is got assigned, and my pods are in progress of creation. Okay, it takes a couple of minutes. Just hold on for a moment. So now, as I said, if I access this public IP, once the pods are up and running, it will send the traffic back to these pods, and I'll be able to see my application launch. Okay, now my pods are up and running, as you can see here. Now let me try to launch this URL. So as you can see, I'm getting a response working as expected. Okay. So that's a basic application, right? So now this will be running on one of the pod. Out of the two pods, it will be hitting one of the two pods, right? So if I keep hitting it, so it might be load balanced between the two pods. Okay, so that's the way my application works. Okay, I hope you guys are with me so far. Okay. All right, so now let's see how I can achieve an auto scaling. So why I need an auto scaling for this application? Let's say in my demo, let's say this has got huge traffic. Okay, we keep trying this website, and at some point your pod will hit a maximum CPU and memory. Okay, this pod will hit a certain CPU and memory, and it will fail to serve the new users. Okay, the pod will get crushed basically. So that's why we need to auto scale these pods. So let's see the current consumption of these pods, right? As you can see, it is 1 millicore. Okay, and this is 9 millicore, 9 millicore of CPU, and the virtual machine that this is running on top is, I mean, the virtual machine has got 2 cores of CPU, which means 2000 millicores. Okay. Now let's see like how we can configure the autoscale. Don't get confused with these numbers. So just to let you know, I'm just saying that this is utilizing this much cores of the CPU. Okay. Currently, it is very minimum 1 millicore and 9 millicore. Maybe my application hit happened on this pod. That's why it's just taking more than the first pod. Okay, so that's the current consumption. Now, let's see how we can achieve an auto scaling. Okay, so to achieve an auto scaling, the first thing is, as I said, an horizontal pod autoscaler, which is nothing but a CPU and memory based auto scaling. Okay, so as you can see here, this is the deployment manifest for a horizontal pod autoscaler. And what I'm targeting here is my application that I have created, which is demo app hyphen php. As you can see here, I'm passing the deployment name here. So this deployment, the number of pods in this deployment, I'm controlling it using the horizontal pod autoscaler. So as you can see here, I'm passing the deployment name here, and I'm giving a minimum and maximum replicas, meaning that have a minimum of one replica, one pod, and a maximum of 100 pods. And based on what? That's a very important thing, right? So based on what it should scale to 100 or it should scale down to 1. So that's what we define it here. So just focus on this part, guys. It'll be quite tricky here, okay, the way this works. So what we are configuring here is 50% average utilization. Let's understand this clearly. What this means here is when I say 50%, here in the deployment, we configure something called as requests. Okay, which means, so what this means here is when we say request of 100 millicore, what this means here is uh, a minimum of 100 millicore should be available for every pod. That's what we are saying here. When we configure a request in the deployment, what we say here is make sure that there is a minimum of 100 millicore of CPU available in my node. If the node is out of capacity, if it does not have a 100 millicore available capacity, it will not launch the pod itself. Okay, so it's basically making sure that at least 100 millicore of CPU is available in the node. Node is nothing but a virtual machine. So let's say in our example, if our CPU on a VM is 1000 millicores, which is one core, and it has got already some 10 pods
already the capacity is over. So in that case, 11th pod cannot be launched on that node. So in that case, a node will be auto scaled. That's when a node autoscaler kicks in. Well, as I show the demo, you will clearly understand it. Okay. So as you can see here, what we are saying here is 50% of the utilization, 50% of the 100 millicore that I'm configuring here. So whatever you say here, there is a link between this and the request that we pass here. So whenever my pod hits 50% of 100 millicore, spin up another pod. That's what we are saying here. So in our case, when we say 50%, it is nothing but 50 millicore. So now try to understand this. The here currently it is 1 millicore. Okay, it's still 1 millicore, and I'm setting a limit of 100 millicore, making sure that 100 millicore is available in the node. And in the HPA, I'm saying that when 50% of the 100 millicore is consumed by the pod, autoscaler pod, which means that when this CPU hits 50 M, it will autoscale another pod. Now we want to see this in action, right? Theory really doesn't help. Definitely want to see this in action. Okay, so what I'm going to do now is I'm going to trigger some load to this pod. Okay, when request keeps hitting, so I can't go ahead and do like this, which is time consuming. So I'm going to trigger some heavy load requests on this URL so that the traffic on my pod grows and it will consume more CPU, so that we can see how the auto scaling kicks in. Okay, so before that, I need to apply this manifest. Okay, the horizontal pod autoscaler. So let me first upload that HPA, and before that, let me show you there is only one node now. Okay, just make a note of this, guys. Hope you're all with me so far. If you can give me a thumbs up, if you don't mind, please. Okay, perfect. Thank you. Yeah, Sanjay, do you have any question? Okay, I think that was a thumbs up.
Yeah.
Okay, perfect. Thank you, guys. All right, so demo is going to be interesting. So now you see, I have uploaded my HPA manifest, right? Sanjay, do you have a question, by the way?
No, I guess I just wanted to lower
Okay,
everything's done.
okay, thank you. All right, so apply hyphen f. Before that, let me show you there is currently no HPA resource. Okay, so now it will create a HPA, horizontal pod autoscaler resource for us. And guys, just whenever it comes to AKS, right? You just understand the concept. Okay, so this YAML file, just a quick tip is we don't want to learn this YAML file, right? In today's AI world, we definitely don't want to memorize something in the YAML. All that is important for us is the concept, right? Nobody, I think, in today's world will memorize manifest or YAML or something, right? So just understand the concept. And you see the HPAs here. My HPA has got created. Currently, as you can see, 50% is the limit I have set in my HPA, which is this limit, and 1% is what the current consumption. 1%, right? So which is very clear so far. So now there is, let's see what is happening in the HPA. Describe HPA. desired count is within the acceptable range. Okay, so there is no need for auto scaling as of now. So this HPA resource that we deployed keeps watching for the CPU on the pods. So how does it know that? As I said, it's calling the deployment here and it's controlling the pods, right? So now there is no auto scaling happening because it's within the range. Okay, now let's kickstart a trigger. Now what I'm going to do is I'm going to create a dummy pod, a test pod. Okay, so I'll also explain what I'm trying to do now. Okay. All right, so what I'm trying to do now is, guys, I have a dummy pod that I just created and I'm inside that pod. Okay, this is a load testing pod. And what I'm going to do from this pod is I'm going to stress test this URL. Okay, I'm going to do a loop hit for this URL. So what will happen, as you can see here, I'm just going to continuously hit my URL. Okay, so as you can see here, it makes continuous request to my application. So which is nothing but the response that we got in the UI. The same thing is happening here. So it is producing a great load on that pod. Okay, let's see the how the pod shows now. You can clearly see there is a growth in this CPU. Right, initially it was 1 millicore, now it is some 58 millicore. So if we wait for some time, there will be huge growth on this pod, and we'll see what happens. Okay, it's going to be a bit interesting. So it takes some time, okay, for the CPU growth. Dev, do you have any questions? See, could see there is a significant rapid increase in the CPU. That's because we are hitting the pod continuously. Because this is the basic concept, guys. So when you have a virtual machine, right? Your, let's say your application is hosted on a virtual machine. When there is a traffic growth, what will happen? That virtual machine will eventually crash. Right? Any website that you take, Amazon or any website, there will be auto scaling logic behind. So whenever there is huge traffic, they scale their underlying resources. That's the same concept here. So now you can see there is a good growth in our CPU, and in some time, let's see what happens. Let me see, describe HPA. So now you can see, right, the desired replica count is increasing faster than the maximum scale rate. Okay, which means that it tries to increase the number of replicas. This horizontal pod autoscaler, see what happened. The number of events that you can see here, it was 4 and it got increased to 8 and then 16. Okay, let's see the number of pods, what it is doing. And now you can see it is evident that the number of pods are increasing. Right, initially we had just 2 pods, and since we are having more traffic and more CPU consumption, the pods are increasing now. Now this is where the cluster autoscaler kicks in. Okay, so This all these pods are running on one virtual machine now, which is a user node pool, which is having just one node. This is what I showed you initially, right? Initially it was one and one. It's just I hope you remember it. You saw it one, and ready node was one. Now just see what is happening here. Have a close watch on this. Your target node is 2, and you can see some scaling activities going on. And why is this happening, guys? Just be very clear. Why is this happening? Because the number of pods are increasing on your node, the virtual machine. And as this grows, right, your node or virtual machine will not be able to handle, because it has to guarantee a minimum of 100 millicore for every pod. And when it's not able to do that, your pod scheduling fails. Okay, let's just have a quick look. So as you can see here, let's take one of the pod. You see the warning here, insufficient CPU. So this makes it very clear, I believe, insufficient CPU, because your CPU has already on the VM has already been hit. So that's why a node autoscaler kicked in, and it is trying to autoscale the number of nodes here. I'll show you how to configure this node autoscaler, which is very simple step when compared to the pod autoscaling. This is very simple. Ready nodes is 2. Okay, so now we have 2 nodes ready. So you can see here number of nodes is 2. And how you can auto scale this node is nothing but you just click on this node pools and scale node pool. Okay, if you choose this option, you will see an auto scale here. It'll be by default, it is manual. So here you mention auto scale minimum node and maximum node. So minimum is 1 and maximum is 2. That's what I've given here. So this is how you configure a cluster autoscaler, which is a node autoscaler. So both the pod and node autoscaler works hand in hand. They're very, without one autoscaling, you will not be able to achieve the complete autoscaling. So now let's see what has happened for our pods. All our pods are running, guys. I hope you noticed this clearly. All our pods, which was struggling to get the hosted on the first node, have been up and running now, which is running on the second node, which is what we expected, right? So now I want to stop the traffic because it's going to be huge. So it has created some, I think some 6 close to 15 pods, I believe. And due to pod auto scaling, or node also auto scaled. Now if I stop the traffic, what is going to happen is so as you can see here, every pod is consuming this much amount of CPU. Now when my traffic reduces, the CPU will get reduced, obviously, right? And when the CPU gets reduced, my HPA will check it, and it's within the threshold limit, so it will decrease the number of pods. And that's going to take some time, okay, because there is some default cooling time. So last hit was, it was trying to scale up to 19 pods. Okay, and now after some time, maybe some 10-15 minutes, it should scale down the pods. And when the pod is auto scaled down, right,
The node will understand it smartly and it will reduce the number of nodes. So this knows that, okay, I'm able to handle the pods that are running because there are less number of pods, and let me scale down. And it will scale down to the default count, which is 1.
All right, so let me take Anand has got any question?
Yeah, this is see,
Yeah,
when the HPA is shoot up,
yeah,
I mean triggered, so it
yeah,
has created 15 pods, right, initially.
yeah,
So I'm just wondering, like, on what calculation it has created 15, but you have given minimum is 1 and maximum is 100.
yeah.
Uh,
Let me explain that.
how it calculates? Yeah, yeah.
Yeah, perfect. Yeah, let me explain that. So here, the a little bit of confusing part here is how did it scale is so you have set up a 50% utilization here, CPU utilization basically. Okay, so what is this 50% is nothing but if it consumes 50% of 100 millicore, it should trigger a pod. So what happened is basically initially we saw 1 millicore, right? So whenever my first pod hit the 50 millicore, I mean we had two pods initially. It'll average out on the two pods. It'll check the average of the two pods. Let's say 50 plus 50, which is average 50 millicore, which is fine under the limit. But when the average hits more than 50 millicore, that's when it will trigger the third pod. Let's say that 50 plus it this had some 60 millicore, which is above 50% when we calculate the average. So it will trigger another pod. And my traffic on the other side keeps hitting the three pods, right? Continuously, the load balancer sends it to the three pods. So what will happen is each of this pod will have more resources, more utilization. So what will happen is this will become some 60, some 60, again this one another 60. So it does some average calculation, and
Okay.
when it's not able to handle, it will spin up another pod. So
Yeah, okay, okay. That's all.
yeah, and when I keep hitting this pods, right, what will happen is at one point it will spin up 100 pods maximum. In case my CPU is that much consumed, it will create 100 pods. That's the maximum. It will not do
Yeah,
more than that. Yeah.
yeah, yeah. Yeah, clear, clear. So basically, it takes the average of currently running pods, and
Yeah,
if it's beyond 50%, then it will create the new one. Yeah,
exactly. It will create a new one. Yeah,
yeah, okay, okay. Yeah, thank you.
sure. Now you can see my CPU has come down, right? Um, so it should reduce some
pods, and definitely it takes some time, okay, because of the default cooldown period. I think some 5 minutes or 10 minutes, I believe. But in a real-time environment, these calculations might be a bit different. These calculations might be a bit complex. Okay, so we need to calculate based on the application. But as a concept, this is what you'll apply it everywhere, right? When you want to use a horizontal pod autoscaler, this is the concept.
and let me check the nodes if something is happening. Node will also scale down. Okay, nodes to no scale activity. So this is going to take some time. Okay, so let me come back to the presentation, right? So what we have here is
What I showed, okay, what horizontal pod autoscales is nothing but the pod, and cluster autoscaler, it is the nodes. Scaling trigger here is CPU and memory for the pod, and here unschedulable pods, right? When the 10th or 11th or 12th pod is not able to get itself hosted on the node, that's when a cluster autoscaler kicks in. Scope is nothing but the scope for this is the deployment. Here the scope is we are applying this at the node pool level, which is very clear now, right? Configuration required. Pods must have the request defined. Request is mandatory, guys. Okay, very important for us to know is uh, For us to achieve an HPA, your deployment should definitely have this request configured, because your 50% that you define here is based on this. So this is mandatory for us to achieve a HPA. And minimum maximum control, it is the replicas. Here it's the number of nodes. How it works, we have clearly seen it. Number of pod to meet the based on the target metrics, based on the unschedulable pods. Example scenario, that's what we have seen. That's the same thing that we have seen, right? HPA detects the target, increases the pod, unschedulable pods, node autoscaler kicks in, and it increases the number of nodes. All right, so I'm open for questions in the meanwhile while this scale down is happening. New size is 1, as you can see here. It is slowly reducing the number of pods. New size 15, new size 1, which you don't see it in the above event. It has taken some time, right? Get pods. Now this is the evidence scaled down to 1. Okay, so a quick reference, one more important point here is, so here, even though my deployment is minimum of 2 replicas, the full control of the number of replicas is done by the HPA, which is minimum replicas is 1. So no matter what you pass here, the HPA will overwrite it, because HPA is controlling the number of pods. Okay, so that's why we see just one pod here. The other pod that you see here is the load generator that we deployed for testing purpose, the dummy pod.
All right, now a scale down should happen here. Yeah, scaling down started, guys. So this will get reduced to one node. All right, so that's the whole setup, guys. So that's the whole demo. I wanted to complete it within an hour. So I'll open it for questions, and also in the meanwhile, let me share my LinkedIn profile and my blogs also. Okay, someone joining now. Okay, guys, just wanted to ask, like, is it all clear? Any confusions? Like, how was my session? Was it all good? Does it really make any sense?
Yes, Anand, like we have never implemented this, but
Okay.
I just got a nice insights of the auto scaling parts. So maybe I'll try to do some demo pods on my side.
Yeah, the good part is you can do this in your home lab. Okay, I'll share my manifest and the PPT also, um, so that you can deploy this in your home lab. Okay.
uh, and after this call, I'll send my LinkedIn profile and also some my website, personal blog, so you can
Go through it, and definitely reach out to me, guys, if there are any questions, right, with AKS or any other.
if I'm aware of it, definitely I will help you out.
And perfect. Yeah, sure. And how many of you are from Chennai? From this group? Yeah. Okay. Okay. Kumar is from Chennai. Arvind. Okay. Perfect. Right. With that, we'll end up the session. And thank you so much all for joining. And hope we have a good learning in the future. Okay. Thank you so much again for all. Yeah.
Thank you so much, Vikram.
Sure. Sure.
Thank you, Anand.
Thank you. Thank you. I'll definitely share it. Yeah. In this chat, right? Can somebody send a message in this chat? I think for some reason this is not working. I can't. Why is this not able to hear you? Because
Obviously, sure.
Um,
Yeah, okay. You send
yeah,
it. We can
I'll
move
send it.
ahead.
Yeah, I'll fix it and I'll
Yeah,
send
yeah,
it.
yeah.
Yeah,
Thank you.
yeah. Thanks a lot,
Yeah, thank
guys. Thank you. Bye bye.
thank you. Bye. Thank you.
Thanks, Anna.